All right, this video is going to go over 6.2b, which is how to graph polynomials. Basically, where I would start with this is you're going to want to factor everything when you see a polynomial, because you can tell a lot about a polynomial when it's factored. You can't tell a lot about a polynomial when it's like this in standard form. So if you approach something like this, you need to factor it. This one would be x plus 4, x minus 3. So that's where I would probably start with these, because what you're going to do next is you're going to take each of those factors, like x plus 4, for example, and you're going to set it equal to 0, and you're going to solve it. So like minus 4, and you'll get x equals negative 4. And then you do the same with like the x minus 3 equals 0, and you'd solve it. So like x equals 3. The reason these are important is because these are x-intercepts. And so like I would have one here at negative 4, and I'd have one here at 3. This is a huge piece of information when it comes to graphing polynomials. So that's where I'd start. But let's go ahead and look at some of these problems. Degree. If you remember from last video, the degree on a factored polynomial is the sum of its factors. So like the exponents here, give them the ones if they're missing it, and then add up those exponents. So this one would be 3. LC stands for leading coefficient. In this case, it's this negative 2 here, so it is a negative number. Now, the end behavior of an odd degree with a negative leading coefficient is up-down arrows. And if you don't know what I'm talking about, go watch the previous video. The number of zeros generally matches the degree. So this one would have 3 zeros. And by the way, when it says zeros, it's just talking about x-intercepts. So keep that in mind. And the x-intercepts here, I'm not going to show my work anymore on how to find x-intercepts because I did that right here. So if you're wondering how I'm doing this, I'm just setting each factor equal to 0 and solving. So that's going to give me, for this problem, one at right here. This one would give me negative 1, for example. So my x-intercepts on this are x equals negative 1, x equals 4, and x equals negative 8. All right, moving right along. Degree. Even this x right here, on this problem, it gets an exponent of 1. So give it the exponent, give this one the exponent, and then add up those exponents. It adds up to 4. The leading coefficient is this 2 right here in front, so it is positive. The end behavior of a even degree with a positive leading coefficient is up, up. The number of zeros generally matches degree. So even though there's technically only like 1, 2, 3 x-intercepts here, you're going to put 4. You're going to put 4. Again, just make it match degree most of the time. And then these x-intercepts, you're going to have 1 at x equals 0. You're going to have, which is this guy right here. I'm just setting it equal to 0. You're going to have 1 at x equals 3. And you're going to have 1 at x equals negative 5, like so. So that's how you would do those two. Now, these x-intercepts, they have different behavior based on what the degree is of that factor. So here's what I mean by this. Go look at each factor. If it has degree 1, it's what we call a straight through. So here's what I mean. If you had the xy axis and you had an x-intercept here, it would cut straight through like that. All right. Now, if it's an even exponent, so like, I'll keep it in blue. So like, look at this one. See how that x minus 3 has an exponent of 2? So even exponent, it bounces. So here's what I mean by this. There's 2 kind of scenarios. It could either bounce and go back down, or it could like be here and bounce and go back up. But it doesn't cross through the x-axis like the first one did. All right, and then if it's an odd, so I don't see any here, but like imagine like x minus 2 cubed. it's going to be a concavity change. These are rare. Okay, these are rare, but it's a concavity change. And what that means is it's like a cubic shape almost. So imagine it was here. It would be like this. See how it's a concavity change, just like a cubic function? Again, those are kind of rare, but the exponent of each factor matters. It makes a difference as to what actually happens at that x-intercept. It's going to help you graph it a lot. So keep that in mind. All right, let's look at these problems. First of all, the degree of number 3. Add up those exponents. It would add to 4. The leading coefficient is a negative number. That means this is a negative even function. So my end behavior is down, down. The number of zeros, make it match degree, 4. The x-intercepts, I'm setting this equal to 0 and solving. So I'm going to have x equals negative 5. I'm going to have x equals 2. And here it is, 2 and negative 5. You see? And both of these had exponent 2, meaning they were bounces. So that's why they did that. They didn't cross through the x-axis. They bounced off the x-axis and went back the same way. So if you look at this, my arrows would be down, down. I've got the correct x-intercepts, and they're both bounces. Good to go. Moving right along. Look at number 4. Add up the exponents. That would add up to 5. So this is degree 5. My leading coefficient, okay. Sorry for the screen jumps. My leading coefficient is a positive number. So it's a positive odd function. That means my end behavior is a down up. And my x-intercepts, again, I'm setting this equal to 0 and solving. So I'm going to have one at x equals negative 3 and one at x equals positive 3. See, negative 3, positive 3. Now the one at negative 3 right here, notice it has an exponent of a 3. That's why it's doing this concavity change there. And the one at positive 3 has an exponent of 2. That's why it's bouncing there, not cutting straight through. Oh, and sorry, zeros, the number of zeros make it match degree, 5. Let's move right along. All right, number 5. Now they didn't do the graph for me. They want me to do the graph. So all this information that I've been getting, it is critical. So here we go. Oh my goodness. These screen jumps are getting me too. Degree. None of these have an exponent, so give them all ones and add that up. That would add up to 3. My leading coefficient is this negative sign. Imagine it's like a negative 1. So that makes my leading coefficient negative. The end behavior, this is a negative odd function. Negative odd functions start high, end low. It's an up, down. Number of zeros make it match degree. And then my x-intercepts here are x equals negative 7, x equals 1, and x equals 3. So if I was graphing this line, the first thing I would do is I would draw my arrows. I know that this arrow has to end going up. And I know that on this side, the other arrow has to end going down. Now, the next thing I do is I put my x-intercepts down on the graph. So like there's one here at negative 7. There's one here at 1. And then there's one here at 3. All right, now if you go look at the exponents of all of these x-intercepts, they're all 1s, meaning they're all straight throughs. Remember back over here, based on the degree of it, if it was a 1, it was a straight through. So all of these are straight throughs. So I put a little $sign when that happens. So I need to cut through here. Now, another handy piece of information to go get is your y-intercept. And you get your y-intercept by plugging in x equals 0 and solving. So like making this 0, that 0, that 0, and actually solving it. So this would be negative 7 times negative 1 times negative 3. That would be negative 21. So down here, I'm going to have a y-intercept at negative 21. Doesn't have to be to scale. That's okay. So this line's going to go and hit this y-intercept at negative 21. It's going to cut straight through at 1. It's going to cut straight through at 3. And I put my arrow off a little further than I should have. It's going to end with an arrow going down like that. Ta-da! That's how you graph it. Let's do another. First thing you should do is go look at the degree. Give this x a 1. So it's degree 3 by adding up these exponents. My leading coefficient is this 3 out in front here. So it's a positive number. My end behavior on a positive odd function is down up. My number of zeros, make it match degree 3. My x-intercepts, I'm setting this guy equal to 0. So that's going to be 0. And then the other one's at -4. So x equals 0 and x equals -4. All right. So the first thing I do is I put my arrows down. So I'm going to have an arrow here, down, and then an arrow here, up, like this. Now, you should also be thinking about all right, let's look at number 6 now. The degree, give this x a 1 and add up these exponents. It would be 3, 1 plus 2. The leading coefficient is this 3 out in front, so it's a positive. The end behavior on a positive odd function is down up. Number of zeros, make it match degree, 3. My x-intercepts, I'm setting this guy equal to 0, so 0, and then x plus 4 equal to 0, so -4. So I've got an x-intercept at 0 and -4. So I like to go ahead and put my arrows down first. Arrow, arrow. I know it has to end like that. Now, another piece of information you should probably go get is your y-intercept. Again, you set x equal to 0 and solve it. So if you set x equal to 0 here and here, you're going to get 3 times 0 times 4 squared. Well, that's all just going to be 0 anyways. So y equals 0 is my y-intercept. So this guy's going to go through the origin, which we already knew that though, because if you have an x-intercept going through the origin, that's your y-intercept as well. All right, so I've got an x-intercept there and an x-intercept at -4. Now you need to label these x-intercepts. Notice the one at -4 has degree 2. That means it's a bounce. And the one at 0 is degree 1. So that's a straight through. All right, so here's what's going to happen. At -4, you absolutely have to bounce. So bounce off. Then you absolutely have to cut straight through the 0. Done. Nothing to it. Okay, let's keep moving. 2 more. Look at number 7. First of all, get your degree. Add up those exponents. Degree 4. My leading coefficient isn't there, meaning it's a 1, meaning it's positive. Okay, this is really bugging me. I'm doing my best, people, sorry. Leading coefficient is a 1, so positive. The end behavior on a positive even function is up, up. The number of zeros, make it match degree, 4. The x-intercepts, set each of these equal to 0. So I've got one at -2 and one at 3. All right. And then you should also probably get your y-intercept. So plug in 0 for x. You'll get 0 plus 2, which is 2. And you'll get 0 minus 3 cubed, so -3 cubed. So that's going to be -54. So that's going to be down here somewhere. All right, let's go ahead and put our arrows down. This is an up, up. So I know I'm going to have an arrow up here, and I know I'm going to have an arrow up here. Now put your x-intercepts down. I've got one at -2. I've got one at 3. And so I start and one more thing, at -3, notice it's a degree 3. That means it's a concavity change there. This guy at -2 is just a straight through. So cut straight through -2. Go hit that y-intercept. Come up this way. Concavity change. Done. I know it looks kind of weird over here, but it is what it is. Okay, last problem. Get your degree. This is degree 4. Your leading coefficient is negative. Your end behavior on a negative even degree is down, down. Number of zeros is 4. Make it match degree. Your x-intercepts are at x equals -1 and at x equals 5. And at both of these have degree 2, meaning they're both bounces. All right, and then you should also get your y-intercept. So it'd be like negative parentheses, 0 plus 1 is 1. And then 0 minus 5 is -5. So that's going to be -50. Okay, put your x-intercepts and the arrows down. So it's going to be a down, down. And then your x-intercepts at -1 and at 5. And you're just going to go and you have to bounce off, hit this y-intercept. You have to bounce off again and connect to the arrow. Although I'm going to redraw that because it looked like a concavity change, even though it shouldn't have been. So let's see if I can do a little better. Bounce off, hit this, bounce off. That's the best it's going to be. Okay, quick recap. You definitely need to know, based on degree and leading coefficient, what your end behavior is going to do. And you need to put those arrows on the graph almost immediately. Next thing you definitely need to know, the x-intercept behavior. Because if you cut straight through when you should have bounced, your line's wrong. And it's not even going to be close. So that is also super important to know. And then lastly, I would get the y-intercept every single time. Just set x equal to 0, plug it in, and go solve for it. That gives you another dot to connect, and it kind of makes things a little easier. But that is sketching polynomials, the basics of it. Hope this video helped.